Well, hello everyone. As you heard, my name is Zoe Ortega, and I'm excited to share my thesis project with you. It is called Drone and GIS Application to Evergreen's Farm. Now, this project started as a collaboration with the farm staff and the GIS professor, Mike Ruth here, and it focuses on how we can use the geographic approach and digital tools to solve a real problem on the farm. At its core, it is a story about listening, collaborating, and using GIS to support small-scale sustainable agriculture. Okay, keep the farm cat Butch, evergreen pivotal cat in the. So this is the agenda that I'll be following today. I'm going to address what the problem is that launched this project, and then I will talk about the research question, the workflows and tools that I developed for this, the key outcomes, and also the takeaways from this. So let's start with the problem. The farm has to track and catalog fertilizer treatment data for reporting purposes to the Washington State Department of Agriculture. And that is for the organic certification process that they do yearly. And that is very rigorous and an extremely detailed process. And so the farm manager has been tracking compost and fertilizer use manually, writing things down, entering them into Excel spreadsheets, and processing the data. It works, but it's slow, it's time consuming, and it pulls her away from the actual field work. She would rather be farming than tracking data, and who wouldn't? And so you can see an example of this Excel spreadsheet on the left for you guys. And on the right, you'll see the farm layouts that she has been building into Excel. And it's full of useful data, but it is hard to access, it's hard to visualize, and it's just not optimized. And so Mike and the farm manager brought this idea to me, and we started working together to ask, how could we make this easier? And that is where this geographic approach came in, to use drones to collect imagery and GIS tools to manage, analyze, and communicate the data. These tools are widely used in large-scale agriculture, but not as much in small-scale community-oriented farms. So this project was also about showing how GIS can support small farm operations. A example that I have that is local comes from Shelton, Washington, and it is the Taylor Shellfish Farms. And they actually relied heavily on hand-drawn maps to manage 10,000 acres and 30 shellfish farms. And then they transitioned into a fully digital workflow using GIS and drones. So now they're using things like Survey 123 for real-time field data collection and drone to map to have these high resolution elevation maps of their tidelands. This helps them in many ways. This helps them reduce seed washout, increase their yield. And they also had this experience when a farm director experienced memory loss after an accident. Their digital system actually kept operations running smoothly through that recovery. And so their story shows how spatial tools, especially a low code and no code management solutions, can improve efficiency, resiliency, and long-term planning, just like what we're trying to build here at Evergreen's Organic Farm. This brings me to my research question. How can mapping with drone imagery and GIS help the Evergreen Organic Farm create a better system for cataloging fertilizer applications? More broadly, throwing my pen, more broadly, how do we build a system that works for the people who actually use it? Something that supports their goals and reduces barriers to getting good data. And so this is essentially showing the requirements or needs from the farm manager. Why do you need drones? The drone imagery, because the farm changes and nothing is to this scale or this current because as like the drone imagery. And then why do you need field data collectors? Because you need to be able to input the amount of like wheelbarrows of fertilizer that you applied to the farm? And then why do you need the report for the organic certification yearly audit? So this is abstracting what the farm manager needs as a process. And then this is how I was going to solve the problem and meet the farm manager's needs. This is my project process, my workflow, and it began with collecting data like drone imagery, and then to set up a geodatabase with ortho images and infrastructure points, then editing, which was developing polygons and grids, and then cartography of the farm plots and infrastructure, followed by integrating tables and applications like past data and survey 123 new data. And then lastly, dissemination materials and reporting. So the reports and dashboards. And this is using all commercial off-the-shelf software. And one thing I want to highlight here is that I made sure that the tools were really low code and especially no code, because that's the key for this long-term sustainability. Is a big hang up with custom apps is that they require developers. And if those developers leave, they are leaving with that experience, and it becomes very hard to update those, if not impossible to keep using those tools after that person is gone. So these dashboards and apps require little to no coding, so they can be updated or reused by others without needing a specialist. And importantly, they communicate the results clearly, helping users understand what the data means and how to act on it. Now, this is my farm map, and it is one of the main results out of this project. And so this begins with drone imagery, which you can see as this like picture-like imagery. And it's not the best quality for trying to fit it on this slide, but it works. And then from there, I needed to create these plot boundaries, and you can see that in this orange. And what that process looked like was several hours sitting at the computer, creating points at each of these polygon areas, and then turning those into lines, and using different tools and geoprocessing tools in the application to then turn them into polygons. And then from there, I needed a 5-foot grid pattern, and that looked like creating a tessellation, which overlaid an entire grid over my map. And then I needed to use geoprocessing tools like Clip to actually get this grid pattern to be precisely within these polygons. From there, in this polygon layer, I had to then create a new field for the name, for the names. And so what I had to do was then use the schematic from the farm manager that you saw in the Excel from what's the problem, and go through and create and label all of these polygons. And then I also needed to create other fields in this attribute table of that layer to be able to have a place for old data and new data from the survey 123 to come into. And then I needed to set up field calculations and summary statistics for when this new data comes in, it is automatically calculated, so it is not on the farm manager anymore to be sitting at her computer away from farm work and doing those calculations. It just automatically does that for her. And so to then take a closer look at the field data workflow, I worked with the farm manager to figure out what information she needed from the field, and then I built a survey 123 form that could be used on a phone or a tablet out in the field. It's set up with conditional logic, and it has the standardized information, as you can kind of see in this like middle one, like the name of each of the plots, so that it minimizes errors, and it also makes it faster, because if you're out there and you've just put a wheelbarrow load on management unit 2, you can just click management unit 2 and input 1 wheelbarrow, and it minimizes the errors, and it's way faster. And then it then automatically just goes into that farm map and has those automatic calculations, and then can go into like dissemination materials from there. So this brings me to one of the dissemination materials, and that is a dashboard. So once the data was all integrated, the next step was to build a user-friendly way to explore and share it. This is where this dashboard comes into play. And a dashboard is really about usability, and they're usually designed to give this information to managers and get that information in just minutes to them so they can explore it. And a dashboard is great because it is very low to no training whatsoever to actually use this. So the farm manager can actually just open up this dashboard whenever she would like to, however she would like to, and explore this map and get the information that she is looking for. And this starts with a prototype, and then she can see what she likes and doesn't like, and it can adapt over time for addressing whatever their needs are for that. So this is essentially like the new workflow. Well, it is like the new workflow. And this streamlines the entire data collection and organic certification process. It's valuable for the farm staff who are collecting data in the field, and the farm manager who needs to quickly access it, and the organic certifier who requires this like very detailed, accurate reporting of these materials. And it transforms this manual tracking into a digital system that's easy to update, saves time, and supports ongoing farm management. And because it's built with those commercial off-the-shelf tools and uses low-code, no-code approaches, it's easy to maintain and scalable without needing a dedicated developer. So this system turned out to be a great fit for Evergreen's organic farm. It solved a real problem that they were having. And more than that, it was built with the user in mind, from the workflow apps all the way out to the dashboard. And the main cost of this system was my time. But since it was at Evergreen, we already have a GIS certificate, a drone certificate. And so the tools, the experience, and the people were already there. So there was no cost to the organic farm to implement this. And that investment paid off though, because it does save time and it reduces the chances of errors in the data entry. And it showed that drone and GIS integration isn't just for large commercial farms, but small farms can absolutely take part in its digital transformation. And because we use that commercial off-the-shelf software and created templates, the tools and database structures are reusable. That means that others wouldn't have to reinvent the program. They just use the tools as they are. And the system is built in a way that makes it adaptable without having to start over. And if you're interested in more details or the step-by-step process, visit my thesis document. It is all laid out there. So this system doesn't just solve one problem, it creates a foundation that can support many aspects of small farm management, and it's built to be shared. A lot of information. So to wrap up, this project shows how drone imagery and GIS can be used as a powerful problem-solving tool, not just for mapping, but for building workflows that everyday farm tasks easier, faster, and more accurate. And what makes this work is that it was built with the farm's input. The design process led to the system that supports long-term management, and it's also adaptable for future needs because it uses that commercial off-the-shelf software. And it doesn't require heavy coding, it's accessible and it's repeatable. And finally, it's scalable. These tools and workflows can absolutely be adopted by other small farms. And whether they're tracking compost or managing irrigation or documenting crop rotations. So in the end, this project isn't just about Evergreen. It's a model that other farms can learn from, adapt, and build on to meet their own goals. It also demonstrates how geography at its core is about people working together, solving problems, visualizing them, analyzing them, and telling a story with the data. Thank you. Any questions?